Yes.
Yeah,
Yes.
so hello everyone, my name is Kshitij and today I'm going to present a presentation related to the topic SAP IBP, demand planning. This presentation will cover majority topics related to demand planning, planning areas, planning level, forecasting, segmentations, which are extensively used in the project. So without any further ado, let's start. Before that, the topics, there are some topics that we are going to cover that are basics related to what is SAP IBP, what are the key features, and what are the four foundational components of the SAP IBP. After that, we can deep dive in the project details that we have made, and then we'll close it with the summary. So first of all, what is SAP IBP? So IBP stands for Integrated Business Planning. It focuses on bringing inventory, sales, financial, and supply planning processes into a single, consistent, and seamless plan. And in turn, we can easily say that it is a cloud-based solution that helps businesses effectively manage their operational and strategic goals in an integrated environment. So, apart from this definition, there are some key features of SAP IBP. There is collaboration in which the users can work on a planning area or a planning level extensively. The user interface is good, and there are real-time simulations with the data that we perform, such as in demand and supply planning. All Apart from this, there is one more key feature of the SAP IBP, that is SAP S4 HANA ecosystem. So this system has been specifically designed to handle various businesses, manage complex supply chain, and streamline operation at various level. Here, every module in this solution provides standardized data models which help provide the real-time supply chain visibility. And there are dedicated and integrated planning environment for SAP IBP, which allows multiple users to perform different simulations, perform analysis scenarios, and handle any exceptions with alerts. So these are all about the key features of the SAP IBP. Now, there is a advantage of using SAP IBP, which one of the features that I highlighted was user interface. So SAP IBP offers two interfaces to optimize the user interfaces, which include web interface for planning and Microsoft Excel for decision making. So in the given screenshots, you can see that the above one is the web interface for planning level, where we create planning areas, we create key figures, we go to data integration jobs, and we create various attributes as well. And in the MS Excel, we usually view these datas in the form of master data workbook, or we review this in the form of edit view, edit planning view, etc. So upon components of SAP IBP, there are mainly four foundational components of SAP IBP. We are going to touch only one of them, that is the demand one. Apart from them, there are three more, that is sales and operation, which is popularly known as SNOP, inventory, and response and supply. So the project detail, let's deep dive into that. So in this project, we have some basic checklist that we would wanted to perform. In that, we in this project, we wanted to configure some SAP IBP system to store the sales history data, which was actual quantity for three products, with the code name of IBP 100, IBP 110, and IBP 120. Now these products are to be sold on a different locations with their code name as 1720, 3710, and 6210 respectively, whereas all these locations have their dedicated customers with their code names. We will generate sales forecast of these products at their respective location and desired customer using simple moving average algorithm. However, I have created key figures with calculated data as well, and I have used algorithm other than a simple average as well, which we'll find out later. But covering moving on to the points, we'll also provide ability to make adjustment to sales forecast of these products, and final forecast for all three products at their location codes will be assigned to customers. So in the first step we did was we created a planning area and we assigned attributes to it. So the attributes that we assigned to this planning area was from the three master data, that was from product master, customer master, and location master. However, we have chosen three root attributes because that is product ID, location ID, and customer ID. The reason for choosing these three root attributes was only to find out the sales forecast data and to filter out the actual quantity, which is the previous sales history for these particular product at a particular location sold to a particular customer only. So that's why these three IDs were chosen as a root attribute. After that, we have used three master data for this project. As informed earlier, we use customer master, product master, and location master. Overall, there were 26 to 27 attributes that we have configured through this master data, and we have taken simple average over all three. After that, we have created planning area where we have stored 26 attributes. We have stored 9 key figures, in which the important one was actual quantity, which covers the sales history, the forecast adjustment, which will help us in manually adjusting forecast for any manually and automatically adjust any forecast. And then there was final forecast, which help us in determining the final forecast of the future sales or upcoming sales in the week or in the timeline. And thereafter, we have created a forecast model related to this. After that, we have created a planning level in which we have created a route called week. So there are various types of time profile level in which we can view the data. Mostly in various organizations, the data are viewed in the form of either technical weeks or months or weeks. So I have chosen my route as a week because it is a standard practice to, and the data was stored in the technical week formation only. After that, the key figures that were used in this project were 9. However, as informed earlier, there were 4 main key figures that were used in order to perform forecasting in this demand planning. That was sales history, actual quantity, sales forecast quantity, uh, s- forecast adjustment, and final forecast. So what we did was, after the planning area was created, we went to the manage master data in the S4 HANA system. We invoked all the three master data datas manually which we have automatically put uploaded from the local system using a data integration job. And there more than 9 to 10 attributes were there per master data, and we have invoked them successfully. After that, what we had done is we invoked these data in a historical data cleanse. We have opened the Excel. We had we had continued with the template of DP 110 historical data cleanse, and we had in the edit planning view we have selected the filter with the product location and customer family, so that the sales history for this attributes can be seen. And after that, we can move ahead with the forecasting steps. After that, for forecasting job, we have followed 2 to 3 steps. First of all, we have created a forecast model, namely the TKJ FM, where we have taken main input for forecasting step as sales history, the actual quantity, which we have mentioned earlier, and we have saved the final forecast in sales forecast quantity. After that, the time period that we have chosen is weeks, and once it's all done, we have saved and we have activated the planning area. Then we have gone into the Excel, and then we have run the statistical forecast using the forecast model that we have already previously created in the S4 HANA, that was TKJFM. And the results were like this. In the sales, as you can see, for all the products, there was sales forecast, quantity forecast, adjustment, and final forecast. These three options were showing for all three. Now, if you take a closer look in the yellow, in the numbers highlighted in yellow, you can see that there are few numbers that are invoked as a forecast adjustment. Due to this, the final forecast quantity appears to be the same as the forecast adjustment. So uh, this is the feature that we had talked about earlier as a part of our project, that we will invoke manual forecast adjustment, so that if a forecast adjustment is created manually, so the final number will be final forecast quantity will deliver as same as the forecast adjustment. Apart from that, we also had touched upon CIDS. CIDS stands for Cloud Integration and Data Services. So it is a cloud-based ETL tool. ETL is enforcement, terminate, and extract, transform, and loading tool for batch data integration. It enables data movement between cloud and on-premise system. It is mainly used for transferring data between SAP IBP and other systems such as SAP ERP or S4 HANA, a flat file, a CSV or an Excel file, or other non-IBP, non-SAP systems. So, in short, the summary will be summary of the project will be the SAP IBP module can fulfill future demand profitability with real-time supply chain management. With technologies and algorithm used in the demand planning, we can effectively forecast future sales and can report adjustment easily while working in a collaborative workspace. We can also create specific planning areas for project-specific demands, and with CIDS in play, we can also fulfill integration with supply and financial planning modules. Time profile and planning levels are created in this project for more granular control. So yes, this is all from my end. Thank you. Hello.
Yeah, Kshitij, it's good. The flow is good and all. Uh, so just a couple of pointers from my end. So you clearly started with what is IBP and all is really good. The starting is good, and you deep dived into like what are the different areas of IBP and all. And just one suggestion is like when you land into the project details, so you can cover up a bit detail like on what the project is like. So here I think it's more about the demand planning, right? So you
Yes, yes,
can talk a little bit of demand planning. What are all the different process within the demand planning that you can explain ahead, and then you can also touch upon like out of the existing or standard demand planning process, what are all the processes that you had implemented or covered up in your project. So that also you can explain a little bit, and then you can start explaining the project details. Okay.
means I should have deep dived into the concept more in the presentation.
Yeah, not into the very detailed level, but at the very high level. Like, so if you go to the slide where you had explained, I think uh, slide 6, right?
Slide this one,
6.
6. Okay,
Yeah, here
components.
you have mentioned like the 4 foundational, right? So
Yes,
here now I think you are going to explain from slide 7 onwards about the demand planning and
yes.
which you implemented your project and all. So you can talk a little bit about demand planning, what demand planning is, etc., etc., and then you can start your project details. So that
Okay,
that will fill the gap between slide 6 and slide 7.
okay.
Okay, and yeah, I think the project details also it's good that you talked about. You took some examples and then you had explained like what are all the things that you went through. But yeah, one another pointer is like usually in most of the projects that we have seen, uh, SAP has already given a standard planning areas. Okay, so it's not like um, it's very rare any customer gonna create their own planning area from scratch and then start filling up their master data and all those things. Okay,
Okay.
so I think even Priyanka has explained where she had used or copied the standard SAP product planning area, right? SAP IBP one.
Yes, yes.
So I would say 99% of our customers are gonna use that. They copy it and they can fine tune it. Whatever they want, they'll add upon that, or also if they want to implement only demand planning, there is a separate planning area, standard planning area. I think SAP 6, I guess, where it's specific for the demand planning. We're just gonna use copy it and then start using that. So it's very rare creating your own planning area from scratch and adding the attributes, master data. So yeah, that one thing you can uh, update in project. Okay.
Okay, okay.
Apart from that, yeah, rest everything is good. It's clearly you had explained whatever the things that are there in the project. But yeah, those are the only two pointers from my end.
Okay, thank you.
Yeah, the the flow was good, Kshitij. What you explained was understood. So from that perspective, the presentation is good. As Pawan mentioned, the other part of our project where we copied planning areas and did hands-on, etc., that can be included and it will make it more comprehensive. But otherwise, what you have done, that you explained well. Right.
Okay.
Okay. Good. Um, is Palak there? We are
Yes,
early. Okay. Palak, you can start.
yeah, I'm just sharing my screen.